In the past 2 to 3 years, we have seen unreal development in the field of AI, mainly in large language model, diffusion models, multimodals, and so on. One favorite interest of mine has been in agentic workflows. Early in this year, Andrew Ng, the founder of Coursera and DeepLearning.ai, made a tweet saying, agentic workflows will drive massive AI progress this year. Ever since this tweet came out, we have seen unreal development in the field of agents as well, where many people started to build autonomous agents, multi agent architectures, and so on. And we have seen many libraries that have come out. It can be in terms of Baby AGI, it can be LangGraph, it can be Crew AI, and so on. So we have seen people building many amazing projects which can actually imitate humans. So typically, what is agents? Agent can act as a human where it can plan and reason based on it. So one thing, if you notice here, right, we have seen many people talking, can large language model actually think? Can large language model actually reason? Based on the multiple research, the answer is still no. Large language models are great, no doubt about it. It can generate very good response. But when it comes to reasoning and planning by itself without any human in a loop, it's not that great. And we have seen models like O1 Preview, which has been out there in the market, which is generating very good results on benchmarking. It is on par with the PhD scholars. And this is where we are leading towards the age of intelligence, where the models are getting better day by day. In this video, we will dive deep into the implementation side of agentic workflows using the library called LlamaIndex. And this is also the part 4 video series of our ongoing playlist of LlamaIndex. The video will cover a crash course on agent that will include the topics like function calling agents plus agent runner. Then we have agentic RAG, where you are combining retrieval augmented generation with agentic workflow. Lastly, we will also look into React agent, which is one such area where large language model can reason, plan with a feedback. This is a very good solution for LLM to reduce the hallucination, and to some extent it can think and it can design a plan, but it's still not that capable to actually replace humans. And we will also look into the project where you will build a search assistant agent which can fetch real-time data and answer to the user query. So let's get started with the code implementation. Alright, so let's get started with the actual video. Before we can proceed with the implementation of agent, let's understand what is agent with an example. Suppose you're going to office tomorrow and you need to make a decision whether you need to take an umbrella or not. What will you do? Firstly, you will go to Google and search what will be the weather tomorrow. Based on the analysis, you will make a decision whether you need to take an umbrella or not. Similarly, agents also does the same thing. Agent have different set of component. Let's start with tools. In tools, it does the search. Based on the search, it will gather the action which has the context, and then using planning, it will make the decision whether it needs to take the umbrella or not. And in order to make this decision, you have different ways you can write the prompt. It includes reflection, self-critic, chain of thought, and so on. And lastly, you have memory to save your data for longer purpose where your agent can remember what to do next time. When it comes to memory, there are different ways you can integrate it. There is a short term memory, there is a long term memory, and you can use RAG as well to get the relevant data based on your previous experience. Memory and planning is where the actual magic takes place. There are so many ways you can integrate these two components, and we have seen multiple people building amazing stuff, experimenting different things. So in our video, we will keep it simple. We will use React for planning, and then we will use short-term memory for memory. So let's start with the code implementation. All right. So we'll begin with the installation. Since I already mentioned, we will be using LlamaIndex. And in order to use a tool to do the search, we will be using DuckDuckGo search. And obviously, you need a large language model. So in order to use a large language model, we will use Mistral AI, and you need an embedding. Why do you need an embedding? In Agentic RAG, you need a component to convert your text into embeddings. This is where you also need embeddings. And how do you configure large language model and embeddings? in LlamaIndex, you can probably check out video 2 in our playlist series. And once the installation is done, you just have to import few statements. So the first thing is we will start off with function calling. So what is function calling? Let's understand function calling. Function calling. So when it comes to large language model, right, it has a limitation that whenever you ask a real-time query, it won't give you the accurate result. Why? Because it's not trained on real-time data. So what will you do in that particular case? So let's take an example. You want to gather the analysis on who was the man of the match and man of the series of the latest test match that happened between India versus Bangladesh. What will you do? So this is where you need to use Quick browser to get the API result, or you can do a normal Google search, get the result, and give it to the LLM. And then LLM will generate the response. So this calling of the function from an API and giving it to a large language model, this concept is typically known as function calling. So in order to build this function calling, you need to have a function that results the actual context. And this is where we will be using a search function using DuckDuckGo. And then you need a large language model. So for large language model, we will be using Mistral AI. So how do you actually configure Mistral AI LLM and embedding model? We already covered this in the video too. And in order to do this, you just have to use Llama Index core from settings. So let's look into every single code line by line. So the first thing is you need to use a tool, which is function tool. And to have that function, you need to have certain web browser API, and we will be using DuckDuckGo search. And obviously we have Mistral AI, which is a large language model, and we have embedding model. So embedding model, typically this is used for Agentic RAG. This is used for Agentic RAG, which is the second topic in our video. This is not required for function calling. This is typically not required for function calling. Function calling not required. For agentic RAG, you definitely need it for converting your text into embeddings. So let's run this cell. And now once this is done, you need to define a function. One thing you need to notice whenever you define a function calling with a large language model, this function should return a data type. So this is the syntax. Whatever it returns, you need to define an arrow mark and you need to tell what is the data type of it. And for most of the cases, it needs to be string. So you just have to keep this in mind. And why we are doing this, you can probably check out the video in the description where I've already covered what is function calling in detail and how you can implement it. So once you define the search, the next thing is you need to define a doc string saying that what is this function doing? So this is very important as well, because whenever you write a code and you're giving it to a large language model, there needs to be certain context. So how can you define a context in programming for any function? You need a doc string. And this is where we have the doc string. And the next thing is you're just defining DuckDuckGo. So whenever a user query is triggered, how will you return the result? So first thing is you will initialize it. So the initialization is very simple. You will just define a variable and you will initialize it. And then once the initialization is done, you will run text function where you will pass the user query and you will return the relevant four results. You can define any maximum result based on your need. 4 is very ideal. If you need maximum results, probably you can go to 10. And once you get the response, probably it's in a JSON format and you need to extract the body out of it. And in order to extract the body, I'm just running in a loop. So this response will contain four elements. Why four elements? Because maximum result is 4. So out of each result, I need to extract the body and I need to save that in a single context. So this is what my function calling is doing. And now what I'll do is I'll just define a search tool. So search tool in LlamaIndex can be defined as function call dot from defaults, and you just have to define your function. So what is our function? It is just a simple search. So this search, whatever you're defining in the function, you need to define it inside your function tool. From defaults, fn equals to search. So you have your tool in place. That's it. This is very simple. You define a tool, you give a user query, and you just feed it to large language model. This is it for function calling. It's very simple. And once you understand the basic of function calling, it becomes very important for you to understand what agent is actually. And agent, typically you have an additional component of planning. This is where React comes in. And I'll tell you everything that you need to know till the end of this video. So make sure to subscribe and like this video. And also share the video so that people who are learning agent, this will be useful for them. So now I'll define the user query. So the user query is very simple. I'll just tell who was the man of the series in India versus Bangladesh 2024 test match. So very simple real-time query that I have. So this happened recently. This was probably in the last week itself. So definitely large language model have no context of it. And then you need to get your Mistral AI API key. Probably I've disclosed my API key, but by the end of the video, I'll delete it. So how do you get this API key? You just have to go to dashboard. I'll just enter Mistral AI, and the link is console.mistralalI.build, and you just have to go to API keys. So once you go to API keys, you can just click on create new key and you will have your keys. So let's get back to the code. And once you have created your API key, just paste it here. And then you need to define a LLM. So I've already imported the LLM. So if you see here, from llamaindex.llms.mistral AI, import Mistral AI, which is my large language model. And you just have to define LLM equals to Mistral AI, where model equals to Mistral Large, which is one of the best model of open source open weights of Mistral AI. And you need to define the API key, which I've already defined here. Okay, I guess Mistral Large is not open weights, but Mistral AI is very famous for their open weights model. All right. So once I've defined the LLM model, I'm also defining embedding model at the same time so that I can override that in the settings. So if you see here, from llamaindex.core, I'm importing settings and then I'm overriding it. So why am I doing this? In llamaindex, OpenAI is the default LLM and embedding, and I don't have OpenAI keys for this particular use case. This is where I'm using Mistral AI and Mistral AI embeddings, and I'm overriding it in the default settings. So this is what I'm doing. So once this is done, I'm defining the function call. So before I can run this, let's just test if the LLM is working fine or not. So in order to do that, I'll just do llm.complete. I'll just tell me about yeah. That's it. So I just want to test if the API keys and LLM is working fine. So the function to run the user query is llm.complete. So as you can see, you have got the result. So I'll just print the text out of it. So I'll just print .txt. So this will just give me the actual response from the LLM. So far, so good. We have already defined a large language model. We just have to define the function calling function. So it's taking some time to generate the response. So as you can see, it has generated a very good response, and this is what we need. We just want to test if the large language model is working fine or not. Now that you have already defined a large language model, there is a function called predict and call. So what this predict and call will do is it will take a function tool, which is your search tool, and then you have the user message, which is the user query, and then you have allow parallel tool calls to be true. So what does this parameter does? So typically large language model, every time it doesn't need real-time search. So only when it doesn't have real-time information, it will use the web search. So this is where you make allow parallel to be true. And once this is done, you have your function calling. So in function calling, when it comes to Llama index, there are different ways you can define it. And I will just show you why do you need these different ways and why agent planner is one of the best method in Llama index to get better result for function calling. So let's understand this difference. So the first thing is I'm using LLM and I'm using a simple function call from LLM itself, where if you see the type of it, llama index dot core chat history type agent response. And now if I print this function call, you have the result. So let's print this. So in order to print, probably you just have to click on dot response. Hopefully, I guess I'm using the right uh, attribute. So if you see here, India versus Bangladesh 2024, India versus Bangladesh match report, it is telling Jaiswal scored twin 50s as Indian registered a remarkable win despite 2 days of no play due to rain. So this is a real-time information. Then you have R. Ashwin bagging the man of the series. So you got the response that you needed. But if you look at the response, there are few unnecessary things that are being added. So this is not required. Why? Because I don't want to know what is the match details. I just want to know who was the man of the series. So this is where a normal function calling from large language model, it is not that capable. So let's look into the second approach. So this is the second approach for function calling agent. So now we are using an agent, and how do you define this agent? You have something called as function calling agent worker. So what I'll do is I'll just run this cell. And previously what you did was you used llm.predict call. Here what you will do is you will use function calling agent from tools, and you just have to add the tools that whatever you have used, the function tool, and then you have large language model verbose equals to true so that you can see what is happening in the backend, and allow parallel tool calls is true because I don't want every time to do the real time search. So once I run the agent, I just have to run this agent by calling dot chat. So more or less, this should also give me the same result as the normal LLM function calling. I just wanted to show you the difference between function calling and agent runner. So now if I print the response, as you can see, the man of the series in the India versus Bangladesh 2024 was not explicitly mentioned in the search result. However, notable performance included Jaiswal scoring twin 50s and Ashwin and Ravindra Jadeja sharing 9 wickets. So I didn't get the response that I needed, and it just gave the entire search queries in the response, which is not the ideal way. The third approach is approach 3, and the recommended one, this is agent runner. So in order to test it out for agent runner, you need something called as function calling agent worker, which I have already defined it here. So if you see here, from llamaindex.core.agent, I need to import function calling agent and function calling agent worker. So now you need to define this. And the approach to define this is again same. You define function calling agent worker from tools, and you define the function, which is your search, large language model, then you have verbose, and allow parallel to be true so that you can switch between it. And now once you run this, there are two ways you can get your response. The first way to get your response is you can directly run query. And the second way to get your response is you can run the chat. So now if I print the runner response, as you can see, let me print response. So it is telling R. Ashwin was the man of the series in India versus Bangladesh test match. India won the two match series by 2-0 with R. Ashwin bagging the man of the series award. So this is much better. So if you look at the response, you actually have R. Ashwin in the focus, who was actually the person behind the victory. Probably there were other team as well. But if you look at the previous response, there was too many context which was irrelevant. You wanted the direct response, and using agent runner you were able to get the direct response. And you can also use chat function to get the result. So I'll just use agent runner.chat. Hopefully it should give me the right results. Okay, chat function hallucinated. It gave Rohit Sharma as the man of the series, which is incorrect. You can go with agent runner.query. Sometimes if you are not getting the right result, you just have to tweak in the parameter, make sure the temperature value of large language model is 0, and you can increase the number of search queries. So this is it from function calling. Let's talk about agentic RAG. And in order to build agentic RAG, let's understand what it is about and why do you need it. So when it comes to RAG, retrieval augmented generation, you have your document. Based on the user query, you will get the relevant data from the context. You feed it to large language model and it will give you the response. So this is what RAG does. So what is agentic RAG? So let's you have a document. Based on this document, you will use the embedding and you will convert your document into index. So index is where you're storing your embeddings into a vector database, and you call this as a indexing. And since you're using agentic workflow, you need to use your index into tool. So what we will do is we will convert this indexing into vector tool and summary tool. So this entire process, whatever you have here, this is called ingest. So let me put this back. So this is where you're ingesting your data and you are defining the tool. Tool is very important when it comes to building agents. Now, what will happen is based on the user query, whatever the question is asked, you have an agent. So, what is this purpose of agent? So, if you look at your document, there are two indexing you're creating. One is the vector index, and one more is summary index. So, whenever a user, if we ask about summary of any document, what agent will do is it will use something called as route engine, and it will go to summary tool and it will give the result whenever the question is regarding the summary. If the question is regarding simple question and answer where you just have to do vector search, this route engine will go to vectors tool and it will generate the response to the agent which will be given to the user. So let's proceed with the implementation for agentic RAG. The first thing is you need to define the simple directory reader. So this simple directory reader is to load your documents. Then you have vector store index, and I've already defined vector store index and summary index here. So probably I'll remove this here. So the first step is to get your document and load it. So run this cell and I need to upload my document. I'll just upload a research paper for time being. I have multiple research papers. So once I upload a research paper, I'll just copy the path of it, copy path, and I will paste it here. So now what I'm doing is I need to use simple directory reader. And in this directory reader, I don't have multiple files. I just have a single file. So I'll define it inside a list and I will load it. So there are two ways you can do it. Either you can create a directory of data and you can pass the directory here without any square bracket. If you have a single file, you just have to use a square bracket and the path of the file. And once you define the path of your file, you just have to load the data. And once I run this cell, it will load the data and it will save inside the documents file. And now what you need to do is you need to split your document inside a multiple chunk. So why multiple chunks? Whenever you are building RAG, you need to give specific information to large language model. If you pass the entire data to large language model, it will exceed the context limit. So this is where you need to use simple chunk so that you can get the relevant document out of it, and you can only pass the required document instead of entire context of the data. So this is where we will chunk it. And in order to chunk your data in Llama Index, we use something called as node parser, and you need to import sentence splitter, and based on the chunk size, it will split your document inside a multiple nodes. So what I'm doing now is I'm just using get nodes from document and I'm saving inside nodes. And now that I've defined the nodes, I just have to create the index of it. So if you look at this document, the first thing is you need to create the document, convert that into embeddings. So here is where you'll also be using chunking, and then you need to create the index. So now we are in this process of creating the index. And in order to create index, you can directly use from llamaindex.core, import summary index and vector store index. So now you have the index of both your documents. One is the summary index and one more is vector store index. So far what we have done is the document is done, chunking is done, and creating your index is also done. Now what you need to do is you need to create a functional tool for both your index, which is the vector store index and summary index. So once you have the index, you need to convert your index into tool. And in order to do that, we will define the query engine. So to define query engine, you just have to use a parameter attribute, which is ask query engine for both the index, which is your summary index and vector store index. Once you define a query engine, it becomes very easy for you to convert your index into a simple tool. So now once you have your index ready, you just have to run this particular cell so that you're creating the query engine for it. Now, as I said you, it becomes very easy to convert your query engine into tool. Why? Because Llama Index have the support of the tools which has query engine tool. And once this is done, you also need to define a router query engine. So why is this router query engine required? Based on the user question, your agent needs to be intelligent enough to route whether it needs to go to summary tool or the vector tool. And based on that, it should generate the response. So in order to do that, you need to have a very good router engine, and then you have a LLM single selector. This is very important, and this is a mandatory parameter that you need to define in router query engine. And since we are using only single LLM, this should be fine. So now once you import all of this, you need to define your query engine tool from default for both the tools. So you need to use the same code, which is query engine tool from defaults for your summary tool and also for the vector tool. And your query engine, it's nothing but summary query engine for your summary tool. And you just have to give a description. So since my data document is regarding the research paper, this agent is useful to summarize the research paper in a simplified way by giving intuitions. And same thing I've repeated for vector tool as well. Whenever a agent or a user needs to ask simple question, I can directly use vector tool instead of summary tool. And now you just have to define your tool. And once you have tool in place, you just have to define a router query engine, which will route the query of whatever user asks. And first thing is you need to define the selector, which is LLM single selector, and pass both the query engine inside a list as a tool. So once this is done, you have the query engine in place. And now what you can do is you can ask your question by just running .query function. So if you look at, let me run this again. So now if you look at the response, okay, why is this an error? API error occurred, status 429. Okay, so what I need to do is I will just run the LLM again. I'll just run the LLM again, embedding again, and I'll run this again as well. Sometimes Collab faces this issue. I don't know why. So no worries. So now what you need to do is you just have to run query engine dot query. And what I'm asking is very important. Give me technical architecture details in the paper. So this is a simple question. I need the answer. So what it needs to do is it needs to route to vector tool. So let me run this again. Since verbose is true, I'll get the result. So selecting query engine, this agent is useful to answer the user queries within the paper and retrieve the relevant piece of information. So what is this description? This description is coming from vector tool. If you look at this, both the description is same. This means the verbose true, the router, it is redirecting to vector tool. And based on this, it will generate the response. The provided context doesn't explicitly details about technical architecture of the paper. It is primarily discuss the capabilities and testing scenarios of method related to character animation and control. So probably there might not be any technical architecture, but there might be some other details from the paper which it is generating the response. And you can also run source node so that you can have the understanding of what is the metadata behind it. But in our case, I don't need this. And I've already talked about metadata in our second video. And now I'll also run the second query. So in this query, if you notice properly, I'm using summarize the methodology from the paper. And now what it will do is it will route to the summary tool. This choice is more relevant because it mentions summarizing the research paper in a simplified way by giving intuitions. So if you look at the description of the summary tool, you have the same thing. Okay, so it has generated the summary of the methodology of the paper. Now I'll just run the response to. All right, so the paper that I'm using is regarding the memo, which is to have the controllable character video synthesis, and I'm getting the result for it. So this is the summary of it. So far what we have done is we have looked into function calling. We have also looked into how we can build an agentic RAG where it is doing the route. If you don't need summary, you can directly use a vector search. Based on the vector search, you need to convert that into a vector query engine. This query engine is converted into a tool. This tool, you need to pass it to a router query. Okay, so far we have completed two part of our video. Now let's proceed with the final part of our video series or this video is React Agent. React prompting is very straightforward. It requires three-step process. The first step process is based on the user query, the LLM or agent will think. So this is the thought process. So once it has the keywords that it needs to think, it will perform certain action based on the environment that it has. So the environment can be a search, it can be calculator, it can be any tool. And based on this tool, it will take certain action and it will give you the context. Once you have the context, it will generate the response. So here is where LLM comes in. Once you have the response, this is what you call as observation. So once you have the response from the observation, agent will think whether it needs to stop or whether it needs to still think and get the better result. So what it will do is based on the observation result that you have, the agent will again do the thought, get the action result, and it will return in a loop until you have the satisfactory result from your observation. And there are two ways you can stop it. One way is you can use maximum iteration. The second way is you can use a output key. Whenever the LLM is satisfied, the output key should be stop signal. You need to give certain stop signal so that the entire agentic loop will stop. So how is this implemented? There is a prompt which is being open source. There are so many libraries that you have. You can check out LangChain, you can check out OpenAGI, you can check out CrewAI. Most of them are open source and they have the React prompt, which is publicly available. So now if you look at this particular output format, you have the thought, then you have the action, and based on the action input, you are getting the result. How do you get the result? You have the observation, which is the tool response. So whenever you write this prompt, right, you also need to consider what will be the input parameter. So when it comes to input parameters, you have action. How do a large language model know what action it needs to take? Whether it is a normal GitHub search, whether it is a weather API search, how is a large language model knowing it? So this is where you need to define an input variable where you're giving the entire tool details as the input within the prompt. So you might see supported action in OpenAGI, which is one of the library and the contributor. In LlamaIndex, you have tool description and context prompt. And in most of the libraries, you have their own way of writing this particular prompt. So one process which is similar is the few shot prompting of using thought, action, and observation. This is common whenever you see any React prompting. This will run in a loop until it has certain output key, if not a maximum iteration. So once this is done, let's start with the implementation of it. And the implementation, again, it's very straightforward. You just have to write 5 lines of code. And as I told, in this particular React agent, we will build a simple project, which is a search assistant agent. And now what you will do is you just have to import from llamaindex.core.agent, import React agent. You don't need any function calling or any function calling worker. You can directly pass the function tool, which is your search, inside the React agent. So now once you run the React agent, you have to define agent, which is React agent from tools. You can directly pass the function LLM and verbose. If you want, you can also give the allow this thing. Let me give allow parallel. Okay, it's allow parallel tools equals to true. Since this is not a function calling, we don't need this parameter, but this depends based on your need. And now what you need to do is once you define the agent, you just have to run a chat. So tell me about AI with Tarun, also do analysis and say, should people follow him? This is a simple query. So now what it will do is it will do the thought. So if you look at the thought, the correct language of the user is English. I need to use a tool to help me answer the question. And then if you look at the action, it is search. How is it getting what is search? Because your search tool, if you look at the search tool, where have we defined the search tool? Okay, so if you look at the search tool, in function tool from defaults, your function name is search. So this is your action, right? Let's get back. So it will do the search. And what is the query of your action input? AI with Tarun. And it is getting the observation. This observation is the Google search, and then it is getting the result. And then again, it will again do the thought. And once it does the thought again, it is asking one more question, and then it has the answer, and then it has the analysis. So now let's print the response. Tarun Jain is a AI engineer who offers free resources to help people learn and build AI. That is true. I'm sharing what is retrieval augmented generation. There are total 10 videos, all 10 are free of cost on YouTube. He has expertise in generative AI, machine learning, image processing. Image processing was what I was doing in my previous internship, and deep learning, which is my current job. Tarun works as a developer relation and data scientist at TI Planet, and is a Google developer expert in AIML. This is true. He has also participated in Google Summer of Code 2023 at CA Microscope and was ex research intern at CCCIR. This is where I was working on image processing. Cool. It has gained so much information about me, and all of them is correct. So now let's look into the analysis. So it has looked for expertise, free resources, industry involvement, community engagement. Should people follow him? Yes, people interested in AI and machine learning should consider following Tarun Jain. His expertise, free education, resources, industry involvement, blah blah blah. At the end of the day, just subscribe and stay tuned for the upcoming videos. So keeping jokes aside, this is it from the video. I hope you got to know what is function calling, agentic RAG, and React agent. There are advanced method also on how you can implement agent, and we'll also have a end-to-end project tutorial as well. So this is the part 4 of Llama Index series. There are 2 more pending videos. The Part 5 will be related to advanced RAG and advanced agent. And part 6 will be end-to-end project using LlamaIndex, where we will typically use agents instead of RAG. So stay tuned, do subscribe to the channel and stay updated. Thank you so much.